This strategy is the +1 strategy. We want our students to understand that when you add 1 to a number, it's the next counting number. So if it was 5 plus 1, they say 5, 6. That 6 is the 5 plus 1. It's just the very next counting number. So there are varieties of math tools we can use to model this strategy. The first example I want to use is 5 plus 1. So what I can do is I can use any concrete thing I can touch, whether it's teddy bears, whether it's apples, anything that you can count. And I want to do 5 plus 1. So I'm going to count out 5 of one object. So 1, 2, 3, 4, 5. So I have my 5. And I want to add one more to that. In addition, we're adding to our pile of things or joining some things together. So I've got 5 plus 1, and now I can count them all up. 1, 2, 3, 4, 5, 6. The next level we want the students to get at is to count on, though. So since we know this is 5, we can count on one more and say 5 without counting each one, and then say one more makes 6. So we can use these, and we deliberately do use two different colors so children can see the two numbers being added together. And also they can think about changing the order. We can have 1 plus 5. It still equals 6. We call that the turnaround principle. So we have these blocks. We also have a math tool called a 10 frame that helps us organize our thoughts based on using the benchmark numbers of 5 and 10. So if I were to write the equation here, so 5 plus 1 equals, what I would do is still take my 5 cubes, only now I'm going to put them on the 10 frame, and you'll see why this is important. By having our full 5 on this top 10 frame, we call that a fast 5. So there's no need to count each one. We know there's going to be 5 right there. And then I want to add one more. I put one more, and then I say, well, how many is that? Now, some students can count them all up, but we want to progress them to understand they can do as much smart lazy things as they can. And smart lazy would be doing, that's a fast 5. There's no need to count those. So they can say 5 and 6. And other children can even realize, as kind of like a picture, that that is 6 objects right there without even counting them. They can tell that that's 6. Now this also can then progress to doing pictures. So if I had 5 plus 1, we could do 5 circles. And then we could either change color of our marker, or for this one we could just do like a triangle. So we're still doing the same thing, only this is the picture level. We have the concrete level, and then comes the pictures. Another example might be 9 plus 1. So if on my dry erase board I can do my 9, I would take my objects and count out 9, but I can think, oh, well, this is a fast 5, and then 6, 7, 8, and 9, and I want to make one more, so I'm having 9 plus 1. So we've got 9 plus 1 equals, well, the 9 plus one more makes that full 10. The whole 10 frame is full, which is why we call it a 10 frame. Then we have another math tool called the Rec and Rec. These are beads for each one of these numbers. So if I were to do 5 plus 1, you'll notice the colors. These are made deliberately. We have the benchmark of 5 we want the children to be thinking about. So if I'm going to do 5 plus 1, I can scoot over those 5 immediately. It's a fast 5. And then I can add one more. And how many is that? Well, I could count them up. 1, 2, 3, 4, 5, 6. But as soon as the children can handle it, we want them to think about that being a 5 and then one more. Making 6. So that's called a Rec and Rec. We also have Cuisenaire rods. These are, they kind of look like a rainbow, but they're kind of out of the usual order because there is a method to the badness. This is the 1 cube, and then we have the 5 and the 10. This is the mid one for 5 and 10, but they're hot colors for a sun, like really hot. And then we have 2, 4, and 8. Those are doubling, so 2 doubles to 4, doubles to 8. Those are your warm colors, the red, purple, and brown. And then we have the ocean colors, the cool. We've got light green, dark green, and blue, which is 3, 6, 9. And then 7 is by itself as black, is a prime number. It doesn't belong with any other groupings. And 1 has the white by itself. So we have the children build the staircase so that we can then build equations. So if we're doing 5 plus 1, I grab a 5 rod. And we always have the staircase here for the children in case they've forgotten what number the rods are, but they learn them a lot faster than the adults actually. So if we have a 5 rod and a 1 rod, we're going to do that together, we can get the 6 rod and show how that does match up. And what you're looking at here is 5 plus 1 makes the 6. We also can see that 1 plus 5 makes the 6. And what's really strange, we can think about it as being 6 equals 5 plus 1, and the 6 equals 1 plus 5. Some ways we don't usually have shown that to the children, but it's super important that we do. And here would be an example of 9 plus 1. So we have 9 plus the 1 making the 10. And again, turning those around so they can see the 1 plus the 9 still makes the 10. and have the 10 equals those combinations. Another way we can show it is on a number line. Now number lines are pretty abstract. So those kind of come in down the road after you've done concrete and then pictures, and now we're going to this abstract number line. So if I want to do 5 plus 1, we're going to find the 5 on the number line, and that's our dot, and we're going to add one more, which brings us to the 6. So we use this as a tool. For 9 plus 1, we would start to our 9, and we would add one more to make it so we know that 9 plus 1 makes 10.